In this section, we will discuss discrete time Fourier transform, that is DTFT, and how to solve the DTFT problems, or how to we can calculate the DTFT of a signal. So before going to the problems, first we will discuss the formula for calculating the Fourier transform of a discrete time signal. The Fourier transform of a signal, or DTFT of a signal, can be written as x of e raised to j omega, which is equal to sigma n is equal to minus infinity to infinity x of n e raised to minus j omega n, and this is the formula for calculating DTFT, that is discrete time Fourier transform. And similarly, there is one more formula to calculate the inverse DTFT, which is written by x of n is equal to 1 by 2 pi integral minus pi to pi x of e raised to j omega into e raised to j omega n into d omega. So these are two very important formulas you need to remember, and this is discrete time Fourier transform formula to calculate the Fourier transform of a discrete time signal, and this is the inverse Fourier transform formula to calculate the inverse of a Fourier transform. So you need to remember these two formula, and we need to check 2-3 points. Okay, here the DTFT of a signal is represented by x of e raised to j omega. This is a notation for representing discrete time Fourier transform, and here you can see that you need to know 2 points. When you calculate the forward Fourier transform, or DTFT, you will use sigma, and the limit is from minus infinity to infinity. And when you calculate the inverse Fourier transform, it becomes integral, and the limit is from minus pi to pi. And another important point you should remember, when you calculate the forward transform, that is DTFT, here the sign is minus and here the sign is positive. And another point, the variable used in inverse DTFT is omega, but in forward or in DTFT the variable is n. Now we will discuss how we can find the Fourier transform of a signal. In this question, it is given that find the DTFT of the signal x of n, where x of n is given by 1, minus 1, 2, 2. So in order to calculate the DTFT, the general formula is given by x of e raised to j omega, which is equal to n is equal to minus infinity to infinity x of n into e raised to minus j omega. And here the signal is given by some discrete values, so we can plot the signal like this. This is a graph, this is n, and here I can mark x of n, and you can see that in this case the signal starts from 0, and 0 the signal value is 1, and here it is minus 1, and here it is 2, here it is 2, means at n is equal to 0 the signal magnitude is 1, and for n is equal to 1 the signal magnitude is minus 1. When the index value is 2, the signal value is 2, and when the index value is 3, the signal value is 2. So this is a signal. So we can evaluate the Fourier transform like this. We don't want to evaluate from minus infinity to infinity. We can evaluate it from 0 to 3. So n starting from 0 to 3, x of n into e raised to minus j omega n. So now our formula will reduce to 0 to 3 instead of minus infinity to infinity. Now we can expand this by substituting n is equal to 0. So in the first case you can substitute x of 0 in place of n, and if you substitute n is equal to 0 here, it becomes e raised to 0, that is 1, plus next n is equal to 1. So you can calculate x of 1 into e raised to minus, in place of n I can substitute 1, so it becomes e raised to minus j omega, plus next n value is 2, so I can write x of 2 into e raised to minus n value is 2, so you can write 2 j omega, which is equal to, one more term, plus x of 3 into e raised to minus 3 j omega. So it's from 0 to 3. Totally you will get 4 terms. Now we can substitute x of 0 here. So x of 0 is 1, so I can substitute 1 plus, in place of x of 1 it's minus 1, so I can write minus 1 into e raised to minus j omega. Next x of 2 is 2, so I can write 2 into e raised to minus 2 j omega. Next x of 3, which is again 2, so you can write 2 into e raised to minus 3 j omega. So your final answer will 1 plus or 1 minus e raised to minus j omega plus e raised to minus 2 j omega plus 2 e raised to minus 3 j omega. So this is the DTFT of this signal 1 minus 1